Now let's think about the example of x squared times e to the kx. I was wrong about this part. This is supposed to be up here, x there, e to the kx. Actually, if you go through this example, it's a slightly simpler than a cosine case and multiply there, because as it's differentiated, it repeats sine and cosine, so the more terms kick in. It's a slightly simpler than that. But what we're going to write down here is the candidate. How is this candidate supposed to look like, and not actually calculating what we just did. It's a lot simpler and it's very similar. So what we have to try is that not just the x squared times e to the kx. You can imagine as we go through this operator, we will have x to the first kick in and x to the second, and 2 times the constant times e to the kx is show up. So we have to try all this a1 and b1x plus c1 there. We don't need this all the subscript because there's only one function to deal with here. So if you try, and you can see after you go through all the derivative, you will have exactly of the form. I'm going to use a prime notation, a prime, b prime x, and c prime x squared back, and everywhere this e to the kx is multiplied. So after you go through this operator, you can reorganize it like this, and like we did last time, if you look at the right hand side, if you want to match it like this, these are all linear terms, so we want a prime, the constant part, in terms of a, b, c, 0, and b prime also want to be 0 because x times e to the kx did not appear in the right hand side, but we want to put this c prime exactly 0. So this will be 3 equations and 3 variables, which are a, b, c there. So from there we can figure out what a, b, c are. So that's how you're going to solve this case, x squared times e to the kx. And x, of course, is a simpler. You only consider a plus bx if this part is simply x to the first. Let's look at this important case, e to the kx times cosine kx.